Have you ever noticed how patterns seem to repeat themselves in nature? You see it in seashells, in galaxies, everywhere. Well, what if the universe itself has a fundamental pattern, a kind of structural echo that repeats from the smallest particles all the way up to the largest stars? At the heart of that echo is one single, very mysterious number, and we're going to dive into it. Here it is, 10 to the power of 24. Now, I know, it's just a gigantic number. But according to one pretty wild theory, this might just be the most important number in the entire cosmos. It's like a cosmic scaling factor that defines the very architecture of reality. Think about it like a musical octave. You know how a C note sounds similar to the next C note up the keyboard, just at a higher pitch? The theory goes that the universe does the same thing, but with its structure, at intervals of 10 to the 24. So the relationship, the ratio between a proton and a sun, for instance, seems to hit this exact number. It's this incredible rhyme across scales we can barely even imagine. So what are we really looking at here? Is this just some random fluke, a massive coincidence that we're reading way too much into? Or, and this is the big question the Sentient-Field hypothesis asks, is this number actually baked into the fundamental laws of existence? Is it, in fact, a mathematical necessity? That is exactly what we're here to find out. All right, to crack this mystery, we've got to start with a really foundational idea. The Sentient-Field hypothesis suggests that the secret isn't in endless possibilities, but in a limited, finite budget. So for a second, forget everything you know about space, time, and matter. Just consider this. What if the universe doesn't have infinite resources to work with? This budget has a name, the qualic quota, or just Q for short. Imagine it as the total number of fundamental slots for experience that the universe has available. It's the finite total amount of variety or information that can possibly exist. This one idea, this single axiom, is the starting block for everything else that follows. Okay, so if you've only got a finite budget, how in the world do you create a universe that looks and feels infinitely complex? Well, you'd need some kind of mathematical engine that can take that simple budget and just generate an explosion of possibilities. And this is that engine. Now, don't let the math scare you. A partition function is basically a way of calculating all the different ways you can chop up a number into smaller pieces. In this theory, this specific function calculates all the possible ways the universe can organize its finite budget, Q, into all the different subsystems and experiences that make up reality. And this is the absolute key. The number of ways you can arrange things doesn't just grow, it grows exponentially. So if you add just a little bit more to the budget Q, the number of potential structures and hierarchies and nested systems you can build just absolutely skyrockets. This is how you get mind-boggling complexity from a finite set of resources. And this chart, wow, this really shows you what we're talking about. If the universe's total budget, Q, was just 10, there would be 42 ways to organize it. But just bump that budget up to 100, and suddenly the number of possible configurations explodes to over 190 million. You can see just how fast a simple resource pool can become a universe of insane variety. Now, with all this explosive potential for new stuff, you run a huge risk: total chaos. To stop everything from just falling apart, the universe needs some kind of balance. And that brings us to our third clue, this cosmic tug-of-war between two fundamental forces. So on one side, you have coherence. This is the force for stability, for order, for patterns that stick around. It's what holds an atom together or a galaxy. But on the other side, you have fertility. This is the drive for new things, for novelty, for life and complexity to emerge from the chaos. And basically, every single thing in the universe is the result of the constant tension between these two drives. And this visualization is just brilliant. It shows where our universe seems to be. Out of all the simulated universes you could have, ours appears to be sitting right on this optimal edge, what's sometimes called the Pareto frontier. It's the sweet spot where you get the absolute maximum amount of creativity and novelty for a given level of stability. It's like the whole system is perfectly tuned. But how does it stay in that perfect sweet spot? The theory says there's a crucial safety feature built in, the quota veto mechanism. You can think of it like a circuit breaker in your house. If the complexity in one area starts to get too expensive and threatens to throw the whole system into chaos, what the theory calls qualic dissolution, this veto just kicks in. It stops that line of development cold to save the whole. Okay, so let's take stock. We have a finite budget, An engine that creates explosive complexity, a cosmic tug of war, and a built-in safety brake. We have all the clues. Now, let's put them together and finally solve this mystery of 10 to the 24. The logic follows in 4 pretty clear steps. First, that partition function is driving this insane explosion of complexity. Second, to stay stable, the system has to follow a really strict rule about efficiency, a kind of universal metabolic rate. Third, when the complexity gets too high and threatens that efficiency, the system can't just keep growing. It has to make a hierarchical jump. It has to fold into a new, higher level of organization. And fourth, when you actually do the math, it turns out that jump has to happen at a very specific ratio. And this is the magic number for that metabolic law. The theory argues that for any system to perfectly balance that coherence and fertility, its metabolic flow, its efficiency, has to stay right around 0.75. And this isn't just some number they pulled out of thin air. No, this is an actual observed value from cosmology. The sigma-8 tension is a famous puzzle for astronomers. It describes how galaxies cluster together at a rate of about 0.75, when all our models say it should be higher. But this theory claims it's not a puzzle at all. It's the smoking gun. It's the proof that the whole cosmos, from life on Earth to clusters of galaxies, is running on the same fundamental operating system. And so, when you take that required metabolic rate of 0.75 and you plug it into the equations that govern the partition function and that veto mechanism, well, one number pops out as a solution: 10 to the 24th. So you see, the big takeaway here is that this number is not a coincidence. It's the mathematical tipping point. It is the exact ratio of complexity where the cost of staying coherent gets too high, which forces that veto mechanism to kick in. And to keep that optimal 0.75 flow going, the system has no choice. It must jump to the next hierarchical scale, to the next octave. I think this analogy from the source material just nails it perfectly. Think about it. Water doesn't choose to boil at 100 degrees Celsius. The laws of physics demand it. In the same way, the very fabric of the universe has a saturation point. At 10 to the 24, it must undergo a phase shift to a whole new level of organization. It's not a choice. It's a mathematical necessity. This whole idea just completely reframes how we look at the cosmos, right? It's not just a random collection of stuff, but a deeply mathematical, self-organizing structure built on these repeating resonant scales. And it leaves us with this one final amazing thought. If this 10 to the 24 octave is just the first one we've been able to spot, what other cosmic music, what other hidden patterns are still out there, just waiting for us to hear them?